It's a whole
You are,
process.
you're in the
Yeah.
barn?
Not yet. I'm just heading out now.
Okay, okay. Must
But
be
yeah, I'll
very,
be
very
that's
cold,
where
huh?
I'll be.
Must
Well,
be.
not as much today, but it was minus 26 with the wind chill yesterday.
My
Today
God.
is about today is only minus 10. My only feels like minus 16 with the wind chill. So we got a
Okay.
10-degree increase. It's crazy.
Amazing, bro. I don't know
Crazy.
how you do it. Okay. Bharat Prabhu is also here. Hare Krishna Prabhu.
Hare Krishna.
Hari Hari Bol.
Your course is going on?
Yeah, and me being here in Portugal.
Remote course. That's okay.
Remote course. You're smiling. Yeah.
Okay.
Good to hear, Prabhus. Jai Prabhupada. Hare Krishna.
Nama Om Vishnu Padaya Krishna Prishnaya Bhutale Srimati Bhakti Vedanta Swami Niti Namine Namaste Saraswati Deve Gaurvani Pracharine Nirvishesha Shunyavadi Parshada Deshatarine Jai Shri Krishna Chaitanya Prabhu Nityananda Shri Advaita Gadadhar Shivasadi Gaur Bhakta Vrinda Hare Krishna 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 Hare 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 Ram 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 Hare Hare वंशकल्पतरुभ्यश्च कृपा सिन्धुभ्यैव च पतितनां पावनेभ्यो वैष्णवेभ्यो नमो नमः. So Hare Krishna devotees, today, so Srila Prabhupada says four things combined together, which is Brahman, Kshatriya, Vaishya, Shudra. Live peacefully, happily. Chant Hare Krishna. Introduce this farm project in America. There is enough scope. So much land is lying vacant. And if there are jungles, cut the jungles, use the wood, just like our Virginia, big jungles, that is West Virginia, before it was Virginia. You cut the woods, you get ground, open field, and utilize the logs for house making, food, shelter, everything there. In Africa, everywhere, the nature's way. Purnamidam, Ishopnishad invocation verse. Everything complete, arrangement by Krishna. We have to little work. That's from Evening Darshan, February 15th, 1977. I like to take his like from 77 many times because that's when he started telling future. That's like 50 years back. Anyway, so today I wanted to see if we can discuss this construction material because now in this Varnashrama college, both the places in New York and Florida, it seems like we'll be doing a lot of construction in the next 2, 3, 4, 5 years. Lots and lots of construction. Lots of people are beginning to feel very interested in joining. Some people have bought properties and we want to build a lot of for devotees. So a lot of construction material. Now I'm thinking what to do about construction, how to do it, what is the best manner to do it. For years I've been thinking all these things. He says, Srila Prabhupada says, food, shelter, cloth. These are three main things he talks about as self-sufficiency. So I like first of all I attack the food aspect. Now I feel like wherever I'm thrown in the world, I will be able to grow food and milk cows and basically live off the land in a more or less. I'm not like a forager yet, yet meaning very far away, but still grains and all and fruit trees and these kind of things I'm able to most of the places in the world I would be able to. But shelter is one thing which I have tried my hand a lot, but never successfully done anything. And still, it is gray area for me. Which material will be best? I mean, I have ideas based on computer research and then physically trying to do something and costing and everything, but a lot of issues are there. So I wanted to bring in our dear Hari Kirtan Prabhu into this discussion because he has been um, many years. I mean, his father trained him in tooling around with everything in homeschooling. So he has been, by necessity, whatever he started constructing. I think he he can give better this background of his. So he has also, we have talked many times about this material, that material. So Hari Kirtan Prabhu, you there?
Hare Krishna.
Hare Krishna Prabhu. No video? Your
No,
dear,
not today.
okay. Your dear video, bearded face mind is like looking. Huh? Okay, Prabhu, let us do this. What have you, could you give a little background of what all construction
So,
things you have, yeah, from childhood or whenever?
yeah, so I started working with Gaudiya Prabhu. Many of you met him, many of you knew him. Um, and my father together on our farm, just out of necessity, just started doing construction and building and picked up a lot of things just from that experience, and then ended up moving into that field. This is when I was 14. I started, and then a few years of that, I moved into the field of building and construction.
So once again, so
And
40
started.
years of age, you were helping Gaudiya and your father to
Yes,
construct
correct.
wherever you are living, you were doing farming, so greenhouses, these kind of stuff.
Not just that, we did full renovations and construction of our
Oh.
living space. So actually, the big project that I started on was we took the roof off of our barn and built a second story so that we would have more rooms for us to live in.
I see. So at that time, what material were you using?
That was primarily the standard material. So lumber from the suppliers and boards and like that. It's very straightforward. What you would expect.
That was in Washington State.
Correct. That is in Washington State. Yeah, well, we lived there, and
Lot of
we needed
rain.
more space.
Yeah,
So no, not so much rain. It's a very dry area.
dry, cold, like
Yeah, dry, cold.
like Nevada, Utah.
Yeah. So that was the beginning, and that's where I started working with construction. I ended up working with a few friends' crews, and like that, different friends of my parents that had construction crews. I ended up joining and training under for a while, and then I began to do that. I worked with various crews around the country as I kind of traveled around a little bit and lived in Alachua for a while. Worked with some construction crews there, and in various places, and then eventually started my own crew, my own business, and took on bigger jobs. And on and off for 25 years, that's basically what I've been doing. There's some short time few years when we were in India, and so I learned some construction methods there because they build very differently, and hired the locals to teach me how to build with bamboo and cow dung and various other things like that. Studied how the cottages were built in the village, the mud huts and the thatch. Learned how the thatch is in Mayapur. Yeah, how they thatch the roofs, and so that was always fascinating. Learned about masonry and did some more research on natural building materials and methods. And in
India or in the US anytime?
This was primarily in India, and then after we moved back to the US, then I did some more study. Before we lived in Washington, we lived in Cottage Grove, Oregon. And in Cottage Grove is where the headquarters of the Cobb Cottage Company is. And the founders of that company were good friends of my parents. So that group is the group that established Cobb as a building material in the United States. So that was I've reached out to them and communicated with them about their building methods and materials and such. So so you can see that's a traditional building style that has been in Wales and England for centuries.
Right.
And so
they have big thatch in England and Scotland and
yes. I mean, you can use whatever roof you want, but traditionally these would be thatched. But it's a mud construction, and it's a wonderful material, but it's very slow to build because of it's not there's not like a superstructure that holds everything up, and so it's called a slump method, and you basically are building the walls out of mud. It's very similar to the way that the mud cottages, mud huts are built in Mayapur. Very similar method.
Mm-hmm.
So yeah, so Yanto is the founder, and his wife Linda, and they founded the company, and good friends of my parents.
These are the British.
Those are the British, yeah. So
So
that's
I'm wondering,
mainly in Wales. You see mainly in Wales, but you will see it around the UK and other areas.
why didn't they have overhang? I mean, and you can explain why the overhang is required generally.
So you don't see it on Western buildings much because roofs are expensive, and so just out of necessity or cost rather, we see that the roofs end right where the wall is. You know, there's very little overhang on most buildings. But really, to protect a building, especially a building made from mud, you need a large overhang, and you can increase the longevity of your building with large overhangs by a huge amount. And so, you know, this one that you're showing now, this is a more traditional style. You know, it's a like a single story, and then this one is the larger house there that looks more like a Victorian style. That one there is cob, I believe. Does that say that's cob? Yes. Okay, so it's cob, and in New Zealand, and that was built to look more modern and more of a large estate house. So, but it's still the same material. So I studied that. I studied rammed earth construction, which is like a concrete or a lime stabilized earth method, and
Study that?
in Vancouver, in Canada, actually.
I see.
There's a gentleman up there that I worked with that was his primary method of building, and it's pressed into earth forms, and it's a very wonderful building material that has been recognized in the United States as an approved building method a lot more than many others. Yanto and Linda have done a lot of work to push cob forward as an accepted and approved building method, because that's one of the biggest obstacles you're going to run into in the United States is you are not allowed to build as you like. There are approved materials, and there are approved ways of building, and so we are restricted on what we can use, and so there's a lot of these alternative methods have been people have been working on getting them approved across the country for decades, but just kind of explored and experimented. And that's actually, you and I met, Nimai, when I learned about the compressed earth block building method. And it's a stabilized earth block it's a larger block. It's not like the size of a brick. It's more like a cinder block size. You can make them any size, really, but generally they're larger. They're compressed. There you go. Yeah, it's like a large brick. They're compressed and they're not fired. They are usually stabilized with lime or cement. And then, as the one architect that we talked with in Bangalore, you can apply tiles to the outside during the pressing process to create a finished surface. So there's a lot you can do with it. It's a very ingenuitive method. And the blocks can be stacked, and the house built without mortar. They can be made with mortar. So it's a lot more novice friendly method. Doesn't require quite the same skill as a mason would have. So I haven't, I couldn't help myself being in this field. Anytime I see different building methods and constructions, I've kind of absorbed that information as best I can, and tried to learn. So that's kind of my background.
Anyway,
and
you're inquisitive minded always. Construction material, you would be very inquisitive because it's your kind of one of the big fields.
Yeah.
Your parents kind of got you to be very inquisitive and encouraged it. Yes, please carry on, Prabhu. So, and then you had your own company now. in
I've managed several companies. Before we moved to Mayapur, I had a company in Gainesville, and I did construction there.
okay.
Mostly renovation. Most of my work there involved renovation. It's just there's so much necessity for that, and also a lot of restriction on new construction and everything. So I avoided that as just it worked well. The renovation worked well. So I got to see a lot of I've seen a lot of what the problems that come up with houses, because I was hired to fix those. And so although I did work with some new construction, I've done some full house builds and such, but my primary experience is in repair and renovation. And the biggest thing that we find in everywhere, not just in this country, actually, I've seen in other countries as well, is issues with mold, bugs, and humidity.
Mm-hmm.
And so with modern materials, we see moving more and more towards plastics to avoid that. Plastics and various chemicals, chemical treated lumber, to reduce that problem and avoid that.
Can you say that again? Mold,
Mold,
insects?
insects, and just humidity, moisture.
Okay.
So most recently, when we moved to North Carolina, we made an arrangement with a devotee here, and we built a cabin on his property that we lived in for 3 years. It was very small. It was 400 and...
Do you have any photos?
I do have some photos. I will post them to the group. I'm not able to
share them also. You don't need to be on the video to share.
So Ramananda actually came and visited us while we lived there. So it was a very small cabin, 420 square feet, and we lived there with my wife and I and the 3 children at the time. And Nandi was born there. So that was kind of an experiment in living space as well as materials, because we constructed that cabin, and our restriction that we put on ourselves was that we would not use any plastic materials in the construction of the building. And that removed so many materials. We could not use standard insulation, because that is essentially plastic and glass fiber mixed with each other. We could not use standard drywall, because that's all reinforced with plastic fibers. We couldn't use normal paint, because that's essentially an acrylic, it's like a latex acrylic paint. We didn't use any kind of treated lumber. We didn't want any chemically treated lumber. So anything that was in contact with the ground, we had an abundance of red cedar, which is very rot resistant. And so a lot of the structure
or where did you get that red cedar from?
That actually was from the farm.
Okay.
So the devotee that we were working with, he's very, very, kind of environmentally or ecologically conscious, and didn't want any toxic chemicals in the land. And he had these piles and piles of cedar logs. And so we hired a mill to come in and mill them for us into beams, and use that as the superstructure of the building. And then we, framed out the inside of the walls in between the beams. And then we did a lime plaster. We bought the bags of lime and sand and mixed it and applied that. And the whole building was insulated with wool, which, being a smaller building, was affordable. We could do that. It would be very costly with larger buildings, but we explored a lot of insulating options using hemp fiber or various wood shavings that would be bug resistant cedar shavings and things like that. Just because of the construction, we had to keep the structure as light as possible for the foundation. So we ended up going with wool, and the roof was a steel roof.
Wow.
And so so that was the construction of the building. And so it was kind of an interesting experience, putting those constraints on myself for trying to figure out how to do this without more modern materials, things that are more simple, more familiar, not familiar, but like more basic. So so that was an interesting challenge, and it created a very beautiful space. I enjoyed that a lot. And in any case, so you and I have discussed many times about how would we build buildings? And I think that kind of one of the biggest things that's come to mind is that in our modern approach, especially in the US, this is kind of an American thing. We tend to think of the building cost and not the long-term cost, not the running cost, the maintenance or the what it costs to demolish a building. And that was actually something I was watching a documentary probably 7, 8 years ago, specifically on this topic, and they were talking about how there's life cycle costs, and frequently to demolish a building is more costly than most people would imagine. So just because of material disposal, how you handle that, and so that it's not a polluting, it doesn't pollute the environment, and it's not hazardous to people. So it's kind of shifted my approach to building. And then also just seeing so many houses, you go in and they have a problem here or there, and it's due to water or moisture or bugs or mold, and having that come up again and again and again, and you're constantly fighting it. To me, at this point, it doesn't make sense to build the majority of your building out of timber, unless you're in just the right environment, it would be a dry environment. It's a rapid material. It's easy to build with, but at this point, I'm kind of leaning more towards earthen or masonry as a building material, as it's you just avoid a lot of those problems.
Okay, so let us go to some structure in this. Why don't we go, because let's go through the different building materials one by one by one, and different climates, pros and cons, however much we can get to till 10 a.m. Let's another one up.
Yeah.
When do you need to leave? So I can focus more or less, or maybe, and we can continue in the next part also. It's a big discussion.
I should probably head out at like 9:30.
So 1 hour with no.
Yeah.
Good. Okay. So maybe next week we bring in more data like Excel and everything. But overall, let's go through the building material this week.
Yeah. So your primary, your easiest, most straightforward, most rapid way to build is going to be what, and this is not for finishing. This will give you a working building, and then you can construct, and that is with logs. It's a very straightforward log house construction. Very straightforward. It's very rapid. It doesn't require a tremendous amount of tools to do it, but it also comes with a host of problems, and solving those problems tends to be challenging. So it's not the most reliable, but it's simple, straightforward, and you can typically harvest the material right off of the land if you have trees.
Okay, I have a lot of questions.
Sure.
Okay, so let me bring up first of all what the log homes look like. So shall I pull up this one?
Yeah, that's fine.
Just tell me whichever one you want to bring up.
The one on that's good. That'll work. So now what you're looking at here, this log construction, this has been engineered to address a lot of the problems of log construction. And so that's where you start to, doesn't become more cost effective than other ways. In fact, this becomes more expensive. So it depends on what you're trying to do. If you're trying to build a structure so that people have places to stay, that was relatively comfortable, and then it's rapid. And this is why you see a lot of the initial structures that as people developed land and expanded in this country, it was log construction. Easy, the logs were there, didn't require a tremendous amount of tools to do.
That's what Robert is saying. In Virginia, you don't leave. So I have been told by an architect that at that time when the colonials first came here, there were big trees because the Native Americans, they were keeping all the trees together. So they were 2 to 2 feet wide trees, 2 to 3 feet wide trees, trunk size.
Hmm.
And a clear cut to get like more, because Native Americans were in a very first of all, population was less, and second, they were also doing a lot of food forests, cutting
Yes.
trees a lot, and they were eating from the forest, and they were doing corn, but it was very limited area, and so they didn't need to clear cut so much area. Now, when the Europeans came, they cut down a lot of trees to grow a lot of grains, and they didn't emphasize on the food forest part at all. So, and for grains, for cows, for their meat and everything. So they clear cut a lot of trees, logs, and they were shipping logs also all over Europe. And the result was, at least in Northeast, when they first came Northeast and the mid East, kind of Atlantic side, like Virginias, Carolinas, they most of the big forests were cut down. And
Yeah.
now the newer forest, now about 100 years back, they started thinking about the forest again. The newer forests are much smaller in diameter, so they don't make such a good log cabins because of that.
Well,
Yeah.
the logs that you're going to use are going to be, you don't want massive trees. It's just
With
it's so difficult to work with them when they're so large. And so actually for log cabins, you want a smaller tree.
uh
A trunk, the amount of weight of a trunk, I mean, I'm sure Ramananda is very familiar, um, is tremendous. To try and move that around, to shift it, even with many strong men, it's a lot.
you would dry them first, right? For a few months.
Even when they're dry, the timber is very heavy. We were working with our cabin with cedar, which tends to be much lighter than a lot of other materials, and even that was a lot of weight to move around. And these were not very long. We would have, I think, the longest one was 12 or 15 feet long, 15 or 16 feet long, I think it was. And they're only 8 inches square, so 8 inches by 8 inches and 12 foot long. And we could barely lift it between me and the other gentleman, Amritanand. We could barely lift it. And then we had three of us. And so to work with larger timbers for this type of construction. So this is what I'm talking about right here. This is a very simple structure. It's simple, it's rapid, you can build it, and then somebody has shelter. It is by no means a
400
finished home.
This is
Huh?
400.
This is what?
400-year old.
Yeah. So it this is like the simplest, most rapid structure. Srila Prabhupada, he was encouraging something similar in New Vrindavan for devotee accommodation. That the houses, they had a Prabhupada cabin or Prabhupada hut, they called them, I think. Anyway. And there's different things, different ways that the buildings were preserved, made so they last. But to make it finished like where most people are familiar with and used to, it takes a lot. It takes a lot. The initial construction is easy and simple, but to finish them out and make them really comfortable is takes some time. And it brings a whole host of problems because the logs stretch and they expand and shrink with the weather a lot more than other lumber because of the nature of the full log being there.
Oh yeah. Because one has seen the doors, which are made from wooden doors. Winter
Mm.
and summer, they close differently.
Yeah. Well, that's even cut lumber. With the whole logs, you actually have to have different frames around your windows and doors, because if you make them too tight, then in a certain season, all the glass will crack because it's being crushed by the building. And then if it's too loose, then the windows will fall out of their frames at another season. So it has to adjust with there's special windows with these log cabin kits and things like that you can purchase. They have special framing that goes around the windows to it that expands and it contracts with the windows. So like I said, these finished ones they have engineered to solve these problems. The old ones, they don't have so many windows. The windows are smaller. The construction. So that's the simplest. Then we move on. Probably the next most simple is going to be what you're used to, and that's the standard stick construction, and that's built with.
Just with the log cabin, I want to understand so many questions.
Sure.
So, what is the difference between this log cabin and which is you're saying engineered compared to this log cabin, which was
So
engineered and you're saying is difficult?
so the finish is completely different. And in order to create that finish on the inside, so every time you add layers to a wall, you're going to be trapping moisture. There's places where moisture can get trapped. You don't have air circulation. And so then you're going to change the entire environment of the wall. So there's a common thing that we run into is that you get an old building and it's built, whether it's logs or it's built with framed with lumber and has like lath and plaster and everything. And it's been standing for hundreds of years. And then someone wants to modernize it. And they come in and they put insulation in the walls and drywall and they do that. And then all of a sudden they have mold problems. They put an AC in the house and like they have mold problems. And it's like, why do they have mold problems? This place has been here for hundreds of years without any mold problems. And now, within 5 to 10 years of modernizing it, you have mold problems. And that's because originally the building was constructed and it breathed. There was no insulation in the walls. It was just an air gap. The plaster was very porous. The boards on the outside had gaps, and so that allowed air in and out. And it's just, it's not such a tightly finished building.
Can you explain why breathing is required?
Why what?
Why breathing is required in a building and why the current buildings cannot breathe or don't breathe?
So you have to have moisture and air has to be able to move, not just within the structure, but in between the walls, in between the layers of walls.
Why?
Without that, then the air becomes stagnant, and then you end up with mold growing. It's like if you have a refrigerator that is off and closed, mold will grow in there so rapidly. If it's not cold in there, then the environment with the stagnant air sealed like that is perfect environment for mold, and so it grows very quickly. So inside the walls is the same way. Now, when you modernize a building, you're actually looking to seal the building up as much as possible to prevent heat from escaping. You don't want any drafts or any of the air that's inside the building to escape outside, because you're heating that air, and that's how you keep the heat in the building, is by keeping that air trapped in the building. So this is what leads to
there's
various
a basic dichotomy between what we are used to and what a simple living would be.
yes.
Because you're trying to heat a home and keep the heat so that because the energy costs are so high with electricity.
Exactly.
And so that's why you don't want the building to be breathing meaning letting the heat out. And
exactly. So you're fighting between that, where it's like, okay, do we trap the air inside and that's how we keep the building warm, and then we can afford the heating cost is much more reasonable and affordable, and then we have to fight with the mold problems, and also air quality. They found that in what they consider a ultra efficient home, air quality is huge difference in air quality. It's so much lower because the air is trapped and you don't get any fresh air into the building. So yeah, so this is it's like a battle. You're trying to, how far do you go one way, how far do you go the other way? Because as you improve the air quality, as you improve the circulation of air throughout the building, you decrease the energy efficiency of the building.
now, thing is that the most of the codes in the US are tending towards, of course, energy efficient buildings, and they want to have that much insulation layer and make sure that the heat stays inside, and that's the current architectural based policy.
Yes.
Now, what do you do? What does a natural building material like log cabin or whatever get around that?
So they're just not as energy efficient. That's just kind of how it goes, you know.
Okay, so one second. So one can put the log building and then try to put like a new log building and try to put an insulation over it, which will keep it insulated. Then what's the problem then?
Then it traps the everything has moisture and humidity. As the seasons change, you have more humidity in the spring and in the fall, and then in the summer and winter, you tend to have lower humidity levels. And so just throughout the season, there's always moisture migrating in and out of materials. The wood will absorb water and then it'll slowly migrate across the wood from whatever's exposed, outside. And then it builds up inside the cavity in between where your insulation is, where your drywall has trapped it and like that. And so, and then of course from the ground, there's always moisture coming up from the ground. It's remarkable how much water just comes out of the ground just through evaporation and such. So it's how to avoid that, how to prevent, even concrete is not. I'm going to share an experience with you. So in Mayapur, we were having a new room added onto the house that we were staying, and the houses are all brick and concrete. And they had constructed the room, but it wasn't finished yet, and so the roof had not been waterproofed. And when they're constructing the roofs, they add like a waterproofing material into the concrete, a rubberizing material, fills all the spaces and everything. So they hadn't done that yet for the ceiling, for the roof. And then monsoon season came, it was pouring rain. And I walked to the doorway of the room and looked in, and there was literally water pouring through the concrete into the new room. Now it was just a concrete room, so no damage or anything. I was surprised because I didn't realize just how porous concrete is. And so finished concrete so even if you have a finished concrete foundation, water will be, like through capillary action, it will be wicked up from the ground through the concrete, and it comes in contact with your timbers, whatever is, anchored to the foundation. So there's just moisture coming into the building from so many avenues.
I see. So how do these buildings prevent this? These new buildings, new log.
By using plastic materials, a lot of things are replaced with plastic. I just see more and more and more.
Like
Anything that is prone.
log cabins, like these log cabins.
Yeah, so in between the logs and the foundation, there will be a plastic membrane. On the inside of the walls, there will be. Yes, Nandi, just a moment.
He's eager to do
Yes.
construction too.
So you'll have a membrane between the logs and the concrete. You'll have typically there'll be a moisture membrane between on the inside of the logs. So you'll have like a house wrap that wraps the inside to prevent the moisture from coming in. There will be various layers that kind of, you're trying to prevent the moisture from migrating. The idea is that, okay, the logs will just rot eventually. You get maybe 50 years or something out of it. And then the logs that are lower down on the building will start to become compromised. And then you have to really look at, doing these repairs. And this is what people would call me in for, is like for all sorts of houses. They would call me in for, oh, well, we have rot that we see building going here, around these door frames, around the base of our walls. How do we deal with this? And so
I see.
it's kind of what I spent my time doing. And so it was really fascinating. I actually was interested, like, why is it that these old buildings, like you said, 200, 300, 400-year-old log cabins, why are they still sitting there? Why haven't they not rotted and fallen down? And yeah, the roof kept them dry, and they they breathed. Just the moisture was able to escape, and so
And how
yeah.
was
So it's
then? How were they heating the house then? How were they
just
living?
with a wood stove. That's generally how it would be done, with a wood stove.
And we'll come to that later. It's like the most inefficient way of heating, right?
I have found it to be very effective. The cost is also comparable. We heated our cabin with wood, and we spent comparable to what we would spend in electricity or gas or something
Oh,
like
wood
that to heat. In fact,
stove.
I
Oh,
found.
wood stove. Okay, okay. Stove is different than a fireplace. Okay.
Oh yes, yes. No, fireplaces are terrible.
Yeah, yeah. Wood stove is great. Yeah, yeah. That's
Wood
good.
stoves are I found them to be very efficient. Very comparable. They can compete very nicely. They require more labor, and if you have your own timber, they can be very cheap too. If you have your own lumber that you harvest yourself and everything, that you have to put out the labor to do it, but cost wise, it's very cheap to heat your building, to heat your house. But as far as otherwise, if you're purchasing the lumber, then it seems to be on par with more modern ways of heating. So
So tell me then, so
cost
if
wise.
one makes a log home and then puts these wood stove, basically one needs to keep on feeding them. That's the main problem. There is
Yeah,
no
that is the main thing, is that you
there
have
is
to keep
no
feeding it.
conveyor belt automatic pick up and
No.
put thing. There must be something. Somebody must have.
Well, that's where somebody has developed the pellet stove. So it's essentially a wood stove, but it is fed with wood pellets,
Yeah.
and the mechanism is everything is fed automatically. So the pellets are metered into the stove very carefully, and you fill up the hopper, the reservoir, and then the wood stove, the pellet stove feeds. So as long as you keep the supply of pellets, then your stove will continue to run. And they have their own. It's like so many ways for people that people try to get around doing labor, or and honestly, there's no way around it. Like, either you're going to pay more for the convenience of gas and electricity, or you have to have the electrical hookup, which that's its own collection, because of the amount of electricity required for heating. Like, that has its own set of difficulties. Gas tends to be the most expensive way to heat, or fuel oil actually is the most expensive. You're familiar with that, Nimai, the New Paltz there, the fuel oil and heating oil. So those tend to be like the easier, but they're more costly. And then you get simpler, easy, like less expensive ways to heat, and that's like pellets or wood. Wood requires a lot of labor. Pellets, the maintenance of the stove is there. So you're not chopping wood and moving wood and feeding the stove, but you have to clean it regularly because a lot of ash builds up very quickly.
Why does not ash build up in wood stove?
The design is different. It's the ash still builds up in a wood stove, and you do have to shovel it out periodically, but it doesn't really seem to impact the ability to burn, to operate. Whereas in a pellet stove, it's much more, everything's much more delicate, and so the ash has to be emptied on a daily basis. And
Oh, daily.
yeah, we looked at this for heating the school that we had hit down here, and just the amount of maintenance that was required, they opted just to go with propane. Yeah.
See. But if one is okay to clean out daily the hopper or whatever the ash in the hopper daily, one can basically make any kind of building and breathing and everything, right?
Yeah.
So that's
And so there's different ways that you can work with this. And propane has its own problems. It tends to add a whole lot of moisture to the air, whereas wood stoves dry out the air.
80 hours, almost 80 hours of lowest setting hopper.
Yep.
So that's a lot, huh?
Yeah, that's pretty good. You know.
If
So
wood stoves which go for a day or two, then that's also good. No? But
yeah, and you can get, there are, you know, if you really look into the efficient models, then you can get, there's various Finnish models, and you get into the Northern European areas, they really know their wood stoves. So Russian and Finnish and Danish construction methods. And they get into brick, the Russians and Ukrainians, they really get into the brick construction where you build a fire once in the morning and once in the evening, and that's it. You just forget about it, and the bricks get hot and they radiate heat out for the rest of the day. So
this is one. So as I understand it, either you have to decide whether you want uh, uh, a breathable home or a non-breathable home to
well,
keep
this
the.
is where we start to get into other methods of building.
Well,
where you
let's
don't have to.
Sure. I understand. So what basically one has to decide from the beginning whether one wants because of the Northeast, like in America, Northeast is so cold and wet.
Yeah.
Even in the winter time, specifically, there's so much snow and rain, and so it's so much of humidity and mold will come in that one has to, and from the bottom too, it's all frozen on all the sides.
Yeah.
That's the reason. I see. What do the igloos do?
That's just made of ice.
Complete ice,
Huh?
only ice.
An igloo is just made of ice, yes. Ice and snow.
So how does that keep warm inside?
Because the snow and the ice, it traps the heat. And so then and it reflects the heat very well. So you build a fire inside. And even though the heat, the air is hot, it doesn't melt the ice. It doesn't melt it so rapidly. But I don't know so much about how that is constructed. I mean, it's not a permanent construction, you know. The idea is a temporary structure. But really, this is where you start to get into earth construction. So
okay, more on log cabin first.
Sure.
And let's see if anybody else has any question. Anyone? Prabhus? For Hari Kirtan Prabhu? So Bharat Prabhu was saying rocket mass heater is king of heating. Very, very efficient, easy to build naturally, very little ash in rocket mass heater, very little wood needed. Very, very, very okay.
Yeah, they are excellent. And that's something that those rocket stoves and the rocket mass heaters, that's something that Yanto and Linda were exploring with their cottages years ago. So anyway, that's a very, very excellent approach. So, but anyway, in the log cabins, so you're working with a whole log, not just a select portion of the wood. And so the entire tree expands and contracts. The outer layer of the tree is sapwood primarily. And so that tends to degrade faster than the heartwood.
Does one strip that wood out?
No, you'll remove the bark and you'll remove the outer layer, like the cambium layer. But the sapwood would remain. The labor required to remove the sapwood would be too extensive. You'd need like a sawmill to make it practical.
Oh, I see. And how would you strip it? Easy to strip, or just you take this?
It's labor intensive. If you use a machine, then they use a debarker, and it has blades on it, and it peels the bark off. By hand, they use various draw knives and
you have to dry this first, like for 6 to 8 months or 1 year, huh?
Yes, that's the best. I mean, obviously you can build them with green, but then the structure will shrink and warp and, So you would debark it, and then you would stack all your lumber for a year, let it a full season, and you would let it dry, and then you would build after that.
And you put what kind of like daub inside in between? Like what is this material?
It's called chinking.
Chinking.
Yeah. So essentially it's like a plaster mixture, but you can use like cow dung, you could use like gobar and make a mixture. Essentially you're filling the gaps because the logs are not going to be perfectly straight. So there will always be gaps in between. And modern chinking is like an acrylic material, comes in a tube, like caulking. And but traditionally it was like a clay or a plaster material. It had lime and clay mixed together, which is why you see that white color.
Yeah.
And that would be packed by hand in between the logs to stop drafts, you know, and also kind of. So then here's the other thing is that you can treat the wood to prevent bugs and mold. And that was with lime. And that's what you see in the UK with whitewash. They would whitewash everything.
In India also, that's why they whitewash everything all the time.
So it's a mixture of lime and water, and you paint it on, and it creates a. You brush it on, and it creates a lime coating that over time just hardens, becomes more and more and more hard as the years go by. So, and that can treat the wood. We did that with our cabin. We treated the plywood, the siding on the outside. We painted it all with lime to create that layer.
So this kind of structure pass the codes, the local building codes, you think?
It's no, our structure definitely did not.
Not pass. Why?
But the log cabins can. You won't get a certificate of occupancy. I don't think you could get a certificate of occupancy in any state in this country with a very basic log cabin. I think they would frown on that pretty much everywhere.
Oh, so what would they want us to do?
They would want certain insulation levels. They would want certain moisture. Like just going through the requirements for buildings, like they get very specific about. You have to have, you know, this kind of like water protection for the roof. This kind of, you know, this is just let me think specifically. So there is specific requirements for vapor barriers. There are specific requirements for insulation. There are specific requirements for roofing, and then how the structure is tied together. This is kind of the challenges that you run into with building, and this is one of the things that I have been puzzling over, and that is that. So when I was taking my general contractor's licensing course, the instructor, he said that you cannot think like a builder when you're doing that course. You have to think like an insurance agent, because all the laws that regulate construction are lobbied by and put in place by insurance companies.
Okay.
And so the laws do not necessarily make sense that, oh, this will make the building stronger, this will make the building last longer. The laws are there, and the regulations that we have to follow are there, that this will cover the insurance companies so that they can reasonably claim that you are covered.
Mm-hmm.
And so a lot of laws don't seem to make sense. Like you look at it and you're like, well, if we built this way, we would prevent problems with the buildings in the future. Why is that not legal? Why do we have to do this other, approach? And that's what we run into in this country. And that is, there are so many, unfortunately, commercial interests involved in every industry, but construction is very prominent. You see it a lot, that we're restricted on what building materials we can use. We're restricted on how it has to be built. And it is unfortunately there to, keep these industries going, whether or not it actually makes sense on the end of construction.
It'll be interesting to find out what else has to be done. How are basically if in these log cabins, these finished ones, what do they do to get under the code? So is it that acrylic, this thing, and what you were saying to make them non-breathable, is that the one, or can one make it breathable too?
I think you could get away with making them breathable,
Okay.
but there are certain finishing requirements. You could probably make it work. You could probably build your own log cabins you could make them breathable, and you could finish them out, and you could get the county to sign off on it. What
Most
you would have difficulty with is
Yeah.
that the whole process would be delayed because they would not be familiar with it. They'd be like, why are you doing it this way? This is not something we're used to. This is, and so it would slow down everything and require a lot of discussion between the county and the builder about why it's being done this way and whether or not, you may have to convince them to sign off on the certificate of
if one is
occupancy.
built, or one is built, then they will become familiar, and then they will let.
Yes. Once the first one is built, then it would ease the whole process, and you just say, okay, well, this one is built in the same way. And then now they are familiar. The inspectors are familiar. The county is familiar.
So
You may run into some areas where they say, absolutely not. We won't let you do that. You have to do it this way. And then that can cascade into a series of changes because
my architect was saying, of course, they are worried about the structural strength, that is primary, but then the secondary is what they're worried about is the energy codes, the insulation. And because they keep on making it more and more insulated because of the energy efficiency. So they would want R18 now, I think, is what
Yeah.
we in New York.
So a typical, an uninsulated, let's see. Let's see. Okay. So an uninsulated log cabin has an R value of like R10, maybe.
Uh,
And that really depends on the thickness of the wall. So if the logs you're working with are thinner, they're like a 6 or an 8-inch log after you peel the bark off and everything, then you're only going to get R6 to R8 because it's about 1 R per inch.
okay.
So if you're able to work with thicker logs, 10-inch, 12-inch logs, then you get R10 or 12.
And
The
depending
thinnest insulation is like a 2x4 insulation. That gives you an R13, if I remember correctly.
So if one, I see. So if one put,
But that will not pass code for an exterior wall. So an
yeah.
exterior wall has to be 6 inches now. They've increased it. You can't do the 2x4 walls especially in the northern areas. It all has to be 2x6 walls. So you're looking at like an R value of R. Let me look this up just so I'm not making up numbers.
So
Okay, yeah. So it's like 19 to 20 and so that's about the code standard for any northern part of the country. Even down here in North Carolina, they require any exterior wall to be R19, 20, 21, like
I
that.
think they're going towards 24 now in New York.
Okay, so they're pushing it even further. So they want you to do an 8-inch wall now. So
yeah, so how about if, I mean, I was talking to one like a natural earth builder nearby. He showed me how to do this. He was doing stick frame, but then he was putting straw bales in the
yeah,
afterwards. So how about that if we have log cabin and then the straw bale and then it is finished with plaster? Have you ever seen anything like that?
that's very similar to what we did in our cabin. And we didn't use straw bales, we used wool. But what we did is we built the superstructure out of timbers. We timber framed the superstructure. And then we filled the walls we did a framing. We framed out the walls so that the insulation would be held in, but we framed out the walls and with cavities like a standard wall, and we filled it with wool. So you could do the same with straw bales, where you pack the walls with straw bales and then you cover with plaster. So that could be done. Now, a straw bale typically has an R value of 30 to 38, depending on the size of the bale. So you'll exceed.
It's good enough then.
Yeah, you'll exceed the insulation standards. Straw bale is a wonderful method.
So cheap.
It can be very, very inexpensive, especially if you are able to grow your own straw and harvest it. Then the cost is is
We have
negligible.
all the material to grow straw, everything, and we just like almost like free. We get such
Yeah,
all.
yeah,
We have cutting, making bale, everything. We have
yeah.
all.
So that method works very well. Again, you have to work with materials. They're going to want the exterior of the building to be wrapped. If you're working with a standard builder or the inspectors, they're going to want it to be wrapped with house wrap. You know, it's like a plastic material and various things. I'd have to look it up, but the straw bale construction, there are very clear methods for building with straw bale because you have to regulate moisture very carefully in a straw bale.
New York is familiar with straw bales.
Okay, because different counties and different municipalities may not be so familiar. So it's been established, you know, within the codes in different places, and so it's not so much of a battle.
Yeah,
it's much easier to.
They are familiar with straw bale insulation.
Yeah, so then you can build what they call self-supporting straw bale, and typically those don't go over 1 story because the walls cannot support a lot. And then you have reinforced straw bale where you have a timber frame construction around it, and that supports the 2nd stories, or it supports, you know, the roof and like that. So
I see what you're saying. So there are ways around. So those need to be researched with if we have because many things are because the biggest, as you were telling me that, and our architect keeps telling 50% is labor in the cost of the building.
oh yes, well, that depends on the building style.
Right. So that's the reason if one is building with materials which the family can do, friends can do, unskilled people can do,
Yes,
then it becomes easier, cheaper.
yeah, yes.
So if
So
there are a couple of people who do logs, we'll come to other materials. Like if they're like family, they can help lift the logs in place and then plaster together and put the straw bale in. You know, that whole cost can be like almost reduced to a large part.
yes, yes.
Or
What just to give you an idea of the standard construction methods. So your foundation goes in, and when the foundation goes in, you don't just pour concrete into the trench. You have to put layers of gravel, proper drainage around the foundation. There's all this steel reinforcement that goes in, and then the concrete is poured. And so it's like there's so many aspects to it, and that is because of the weight of the buildings and, you know, everything that's all engineered very carefully.
that one has
Then
to give it to somebody to do. Like
yeah,
also
but it gets quite complex. Then you move into the actual framing of the building, and the whole building is framed. That has to be built in such a way, you know, whether it's single story or 2-story. There's regulations on trusses, the spans for everything, because the lumber can only hold so much weight and what you're working with. So that requires, you know, certain knowledge. It's not something that is so easy for unskilled person to do. Then when you start closing in the building,
I mean, the plan won't be, one can't even build without the engineering like plan being submitted to the the town okaying it after the architect or the engineer's stamp on it.
yeah,
And they come and see the foundation once it is laid out. Before you
yeah,
start the structure, they'll come once to see that. And then once you build the structure and then you want to start finishing it up, and then they want to come once and check once. And then they'll
yeah.
come for the last time.
Well, they will want an inspector to come at each stage before it is closed up. So they want to have an inspector see the foundation before anything's put on it. They want to see have an inspector come to see the frame before anything is put before it's closed up, so they can see how the wall is constructed. They will have an inspector,
There's
you
no
know,
question
at every
of,
stage.
yeah. So all these will be wherever the professional is required and will according to the code that is there. But
Hmm.
I'm mentioning the other part, which which the people can do, the family can do, right?
Well, when you work with when you shift to a different building method, then the so kind of what I was getting at is that with a normal construction, it seems simple enough. You build with 2x4s, you put your drywall on one side, your siding on the other, and there you go, and your insulation in the middle. But really, actually, there's like 1, 2, 3, 4. There's like 7 or 8 layers to a standard wall.
I see.
And so each of those layers is required by code. And so this is why, building.
Can you tell us what are those layers?
Yeah. So then going from the inside of the building to the outside, you'll start with your drywall. Then you will have your vapor barrier, which is on part of the insulation. It's like a paper.
Don't forget paint on the inside.
Well, yeah, if you want to count the paint.
Yes, sir.
We can count the paint.
Paint.
So yeah, you'll have your plaster, your mud, and your paint. So your finishing coat. That's your finishing, and then your drywall. Then you'll have your vapor barrier, which is attached to the insulation typically. If you don't use that, then you have to apply that. You have to staple that in separately. It's a paper vapor barrier. Then your insulation and the wall cavity. So that's your 2x4s and the insulation that fills the space in between. Then you have your sheathing on the outside of the 2x4s. That's attached to the wall to give it that lateral rigidity, lateral strength. And then you have another vapor barrier there, and that is brought in. That's attached to the sheathing. It's stapled to it, and that's before any windows go in, because the sheathing has to be wrapped. Not the sheathing, sorry. The vapor barrier has to be wrapped around the window openings, and the flashing has to be applied to the opening before the window goes in. Then all your windows go in. Then you have all the seams around the windows are all taped. And then you would have, on some buildings, they'll add another layer of insulation, like a radiation barrier. It's like a reflective barrier. So it helps to reflect heat away from the building. So
sheathing, then there is vapor barrier, and then what is the layer?
Then it's like a radiative, it's like a reflective foil type insulation that they'll put over the top of everything. And that just helps reflect heat off the building so they don't heat up so much in the summer. Or it'll trap heat in the building. It improves the insulation value. Then your siding will go on over that. And then all the joints around all the windows and everything, it's all caulked. It's all sealed. And then you paint the exterior of the building. So now
one, two,
it's like 7 layers.
3, 4, 5, 6, 7. It's coming to be 8 because of the paint.
There we go.
Sorry, guys.
No, it's okay. So with the inspectors and everybody, they're used to seeing this kind of thing when you start to build with a straw bale, or you would want somebody to either they have to be familiar with it, very familiar with it, that they are going to advocate for doing it as there's a standard way that you do it that's approved, or you would want to work with somebody that is very familiar with it. They know the codes, they know it's accepted, and they can advocate on your behalf with the county that, okay, this is how straw bale is constructed. These are the layers. This is what passes code. Because you're going to run into those, if you don't have that, you're going to run into those issues with construction. And straw bale is well established in this country. It's you can find people, if you're interested in doing straw bale, the way I recommend it is that you do a seminar, a straw bale seminar, and you have one building that you're going to do, and you bring in a bunch of people that are going to build, and you have the coach, the person you hire, the coach to come in, and they charge all the different people who are attending the seminar, even people who they're just like, oh, straw bale seminar, I want to go and take part in that. And then that building is constructed as a learning experience. for
I did that in
everybody
Nashville,
involved.
Tennessee for a Cobb cottage. This lady had
Yes,
her whole house and bathroom built by people who paid to go and build it for them.
exactly. And then you get the experienced builder who's very familiar with it, with the codes, with how everything is works, and how they can negotiate with the county and everything. And then you get all this labor that comes in that is interested in learning, so they're paying to build your house for you. And you kind of builds like this whole it sets the stage. And then once that's done, then you've been through the whole experience. A lot of the whoever's involved in the project who's there, they've been through the experience, and the county has also interacted with you. And so you've kind of like crossed all the barriers. You know, you've done that. So then it sets the stage, and you can go from there and build more buildings. It's much easier.
So when one is building, let's say, a log cabin, logs. So this is only one part, and I mean logs plus what is it called? The straw bale plus log. This is only one layer.
Yeah. Well, then you have plaster on the inside, because with straw bale you have to coat it with plaster. So you're going to put a wire mesh, and then you'll put your plaster on top of that.
So the vapor barrier, no need to put, because
I would have to look up the specifics. I don't want to say for certain, but from what I understand, you don't want the vapor barrier because you don't want to trap the moisture inside the wall. See, with the standard walls, the only thing that is going to degrade inside a standard wall is going to be the framing and the sheathing. Everything else is plastic. The vapor barrier is plastic. Your siding is cement or plastic. The insulation is plastic. The drywall is treated with chemicals to prevent mold growth. Like there's so but it also will mold. There's so much, so really your framing and your sheathing are the only two things. And the sheathing typically is treated with something now that prevents the mold growth. So, they're not really concerned about moisture getting trapped in the walls. So
this sheathing also one won't do.
no, that would not be. So with a straw bale, typically, from what I understand, and I don't have so much experience with the construction. I've worked a few times with it, but you have your straw bale, and then you have
Well,
your
the sheathing wouldn't
mesh.
require because the bamboo the wood because in a standard stick frame house, the 2x4 2x6 house, you need, like you said, the sheathing is 4x8 sheets of chipboard that will provide the diagonal and lateral
Right,
strength.
exactly.
Whereas
Which,
if you in a straw bale,
yeah,
the straw bale is just filling, right? And then it's the timber frame structure that will offer all of that
exactly,
lateral resistance. So
exactly,
you wouldn't
exactly.
need any of that sheathing. No,
Right.
that's certain.
And so typically you're gonna tie onto the bales using various staples and mesh and stuff like that. Not mesh, but like wire. You're gonna tie a mesh layer onto the outside of the bales, and then the plaster will be applied to that mesh, and it clings to the mesh. And that's how you finish your building off. Now, what I've found with straw bale, cob, any of these more natural building methods, but that are kind of water sensitive, it's really, really necessary that you have large overhangs, large roof overhangs.
Yeah.
For our little cabin, we had an overhang that goes 4 feet out from the building. Now, I don't think you need it to be that large. Probably 2 feet is sufficient. I think most buildings have an overhang which is like 6 to 9 inches. And so the walls are exposed to a tremendous amount of water from rain. And you would need to go, 18 to 24 inches to really protect a straw bale or a cob wall.
So going through this log, so log won't require this radiant and reflective foil, or can we use something?
I think they would want that. Traditionally, it's not there, but I think that they would want that. I don't know exactly
Even aluminum foil?
Yeah, I mean, I mean, you can add that, but what that does is that adds more layers on the inside of your building.
It's on the outside, right? Radiated.
If you put it on the outside, then you don't have the log appeal, which is kind of the main reason people go with log construction, is that it looks a certain way.
And the siding? Not
They don't usually put any siding on log buildings.
so, but then it will degrade, and that's why you're saying about overhang.
Yeah.
Or one should be okay. If I can't put the overhang and I don't want to put the overhang, so I will put the siding.
Yeah. So, but solving all of these challenges, this is why I've kind of leaned towards other methods of building, because you're kind of combating the natural difficulties with working with wood as a building material.
Okay.
It's just the mold wants to eat it, the bugs want to eat it, it wants to break down,
Yeah,
So
write down all the disadvantages.
Can I
Yes,
can I
please.
read something just I just did a quick search here about films exterior radiant insulation film in Ontario. It's not required. Rather, they rely on the thick straw walls, which offer plenty of radiation value, and also
okay.
they depend on proper moisture management, like wide overhangs, like you said, good
Mhm.
plaster and drainage, and breathable barriers to stay dry and warm, as sealing them with low perm materials like plastic traps moisture and causes mold. So that extra film, radiant insulation film on the outside, would be defeating the whole idea of a
Right.
straw bale with its massive insulation value and the breathability of it. It seems like straw bales are really cool. What do you call it? Middle ground between having the breathability and simultaneously that high um,
I think it's an excellent
insulation
building
value.
material. I think that straw bale is really wonderful to work with. And we lived in a straw bale house in Ashcroft, just outside Sharonagati for quite some time. They're
Yeah,
wonderful buildings.
straw needs
They're
to
really
breathe to
pleasant.
prevent rot.
Yeah,
So
absolutely
any
has to.
plastic vapor is a big no-no on straw bale.
Now,
Basically,
one thing to keep in mind, if you were to go in that direction of building with straw, and you had the option of growing your own straw, the type of straw also makes a big difference. So typically what you'll find is wheat straw or oat straw, and those are okay. That straw works just fine. But the absolute best to work with is rye straw, because the rye straw naturally has a wax that's very waxy. The stalks are very waxy, and so then they resist mold very well. And they tend to make the best straw bales. So that should be taken into consideration as well. It's difficult to find rye straw if you're purchasing it, but if you're growing it yourself, it's not a problem.
so you think rye straw is better, huh?
Rye, yeah, RYE, rye.
Rye is
Where we are, rye, I think, is very, very, very common because there's a
yes,
lot
yes.
of there's a
Yeah,
lot of wheat being grown around
rye is
for yeah.
Yeah, so rye is good. Wheat and oat straw is more common, but it works. It works. But the absolute best, if you have the option, is rye.
So it looks like
Whatever you do, don't use hay
Right.
because it's a high moisture content.
Yeah.
Rye, hay and straw are not the same.
Yeah. So so that the straw bale with a timber frame construction, that could be very good. I would recommend just because of the the engineering of it and the way it really is kind of particular how you build. I would get somebody who has a lot of experience with it to assist with the first one, and then like I said, kind of
an architect can design the log
Yeah.
cabin We will go through the stick frame comparison, and I'll try to bring in the architect to compare the two and see. And the big consideration is building by the family and friends, unskilled people. That
That
is
I think would be a little difficult with straw bale. You could do it, but I think it would
probably
not be as
so
not be
easy.
as
Just place it there, and like there is nothing to it, no? Strawberry.
yeah, it's possible. It's possible. The timber framing can get complicated. It's less the actual construction, and it's more the like you'd have to see what is required by the county. If it's a relatively simple wall, like you were saying that there's no vapor barriers are used, and you know, like you build very simply, then I would say that's not a problem.
That
But
will
if
be okay. Just build this plaster and
yeah,
whitewash.
that the plaster is easy. What we did it with the cabin is we invited everyone to come and insulate the walls because it was all wool, so it's not a hazard or anything. We had the kids were just stuffing wool in the walls and the whole party. And then when we did the plaster, we did the same thing. We just gave everyone gloves and we said, "Look, just throw it on the walls and spread it out with your hands." It's like very, very, very simple. And it was great. You know, we had the whole community come to help, and we invited people. We made a bunch of food and fed people while they were there, and we just everybody hung out. And it was very nice. And so, you know, because that type of construction was very straightforward, we could involve everyone. It wasn't like, you know, oh, this is too complicated for the children to be involved with this or that. And stacking the bales like that is they can be involved. Like, you know, even kids can be involved.
I've also done it.
So it becomes very straightforward. It's just I don't know what the codes will regulate and what they require when you get into the more complicated stuff. Then it's
The
okay.
disadvantages you were saying, the bugs, they
So if you use rye straw, the bugs don't, and just straw in general, the bugs generally they do not like. There's nothing for them to eat, and so they don't generally. It's not a problem. The mold doesn't like to grow on the straw unless it becomes very wet.
What about log cabins?
Log cabins, the bugs love it. Oh, they will burrow into the logs and eat your home.
How about putting like one straw bale inside, one straw bale outside, and then finishing it outside with siding or something?
I mean, you could do that, but then your walls would be incredibly thick. I mean, it would be, yeah. But
there's so much space in the farm, always.
yeah, I think that there's better methods that we can approach. You know,
5 feet walls. Then you don't even need to heat it so much.
right, exactly. Just turn on a light bulb and the house is warm. So.
Our own bodies would make it warm.
Exactly. So, you know, I think there are other ways that would be more material efficient and such when we start thinking about that.
What was the solution that you were trying to reach by doing double thick walls?
Protect the timbers.
The logs, because
you'd be surprised
to not have the timbers exposed.
Yeah, you'd be surprised. Bugs, rodents, all sorts of things. They'll find their ways inside your walls, and you'd wonder how they did it. Like this wall is sealed. How did they get inside? It's unavoidable. There's just, you know, there's always going to be some living entity that is looking to make use of a space. So rather than try and prevent it, I would prefer to work with materials that, you know, or just have the approach that, look, we're not going to try and stop it. We're just going to work with it and live with it. And, you know, sometimes I wonder, like the trade-offs, you know, these super energy efficient homes. Really, if you're growing your own, if you have a wood stove and you have your own timber and you harvest it and that's how you heat your home, honestly, you can in most places, you can keep your place quite warm without needing an ultra efficient home. And you can prevent mold by keeping the home you know, breathable. And moving in these directions of ultra efficient homes is necessitated just because energy costs is going so high, and we heat with electricity or fuel oil or heating oil, or, you know, and it becomes, you know, unaffordable. So that's kind of where I lean towards keeping it as simple as possible and actually shying away from more modern methods. You know, it's like, okay, let's just heat with wood. The wood also dries out the air in the house, and, you know, It can become the air in the house gets very dry, and so that actually helps preserve the house. So that so that's so for straw bale and timber construction, I would just kind of lean in that direction. Also, the use of air conditioners can be problematic. This is one thing that comes up. So I've seen this over and over again. You'll get an old building and 100 years old, and they'll modernize it, but they put an air conditioner in. So what this does in the summer is that the air outside the building has a much higher humidity level than the air inside the building, because the hot air can hold more moisture. So we've all seen, how water condenses on a cold cup when you put water in it. The outside of it gets all sweaty. So your house does the same thing in the summer. If it's air conditioned really heavily, the inside of the house is cold, the outside of the house is hot. And when air migrates through the layers of the house, inevitably it does, then it hits something cold, a surface, like the inside wall of the drywall in between the layers. And the air condenses and drops moisture inside your walls. And that whole problem could be eliminated if we didn't have to run AC inside the house. If we didn't run it, if the air temperatures inside and outside were basically the same. So,
and where the insulation is very good, then may not even need because I'm thinking about all these palaces in Rajasthan. They have like 3 or 4 foot walls, thick walls, and
those are all masonry.
And then the plaster.
Yeah.
It is like so cool in the summer because it's so hot, no? It's like
yeah. So that's an entirely different category of construction. So when you build with masonry, you're not looking at an R value. I mean, they will do that. Still, with masonry construction, they will put styrofoam and they will put air gaps in between the walls and such. But if you look at traditional masonry, you're not looking at trapping the air inside the building. You're looking at trapping heat within the thermal mass, within the mass of the masonry, of the earthworks, whatever it is. So you're looking to raise the temperature of the actual material that the building is built out of, and then that will radiate the heat into the living space, or it will cool the living space. It'll prevent the heat from migrating inwards. It works as a heat sink.
Does regulate like that?
No, straw bale works by creating a trapped air in all of the cavities of the straw. So the straw is all hollow stalks, and so it traps that air, so the air doesn't move, and so then the heat doesn't conduct through air very well. And so when you are able to stop air from moving, it works as an excellent insulator. And so that's how insulation works. The more air you can trap in a space and prevent it from moving, then the less heat will migrate across that space. And so that's where straw bale or insulation, wool, all of those things, that's how that works to keep your building warm. But if the air inside the building and the air outside the building are being exchanged through drafts and open windows or whatever, then you have no insulated value. It doesn't matter how thick your walls are. So yeah.
If one really, you're talking about bugs and rodents for log cabins. How about if it is really plastered well from outside and really siding everything? Still, you feel the bugs and rodents.
Oh, I mean there are definitely ways you can if you whitewash your timbers, that really helps tremendously to protect against using plaster and whitewashing the timbers. Not a gypsum plaster, but a lime plaster. So gypsum plaster is what drywall is made out of. It doesn't really do much. It's not very alkaline. It doesn't do much to protect the timbers. You would want a lime plaster because that is a very alkaline substance, and that is going to prevent the bugs will not eat it. It's toxic to them. And so that will protect your timbers. The overhangs being the biggest one, the bugs and the mold and things like that will not eat the wood so much if it's dry. They will start to eat it very rapidly if it becomes damp. So keeping moisture off the walls. really you want to keep them as dry as possible, as constantly. The worst decomposition happens when something goes from being dry to wet to dry to wet, back and forth. So you'll see, I'm sure you've seen this in India, and you'll see like where you have a dock in the water, like a pier, and the section of the legs that rots is the section right at the water level. Not underwater doesn't rot, and above the water doesn't rot, but right where the water is. And that's because it's constantly going from being wet to dry. And so with large overhangs, you can keep the water off the building. That'll protect it tremendously. And then you use whitewash or like a lime plaster to protect the timbers, and that works. The thing is, I don't know if any of this will pass county regulations. I don't know if they'll look at that and go, yeah, that works. You know, I know that it works. I know that it will protect the buildings. I don't know if the counties will accept that and be like, yeah, that's acceptable. You know, we'll sign off on it. And that's where you run into your difficulties. That's where you run into your problems.
So I know you have to go, Prabhu. I will just kind of close it out. So we are talking only about not the foundation. Foundation, you have to get the professionals to
Yeah.
do. Land clearing, building septic, all these things. Septic we can talk about. Sometimes the codes allow, like in Florida, it allows for composting toilet. We'll talk about later. But talk about this is about the inner, the whole layer, the walls. That's
Yeah.
the now about log cabins or not the roof, just the walls. And the overhang is one way to protect and whitewashing, and otherwise, if it is possible with the code, then it is possibly we can use the straw bale log cabin with plaster, that could, with the big overhang of the roof, that could solve problems, correct?
Yeah, that could be very effective. Yes.
And especially rye straw bale, because it's so cheap to grow, and if the logs are available on the farm, and the space is not a problem, so wall thickness is not a problem, so that could be one way to do it. But as especially because if the home uh, family and friends could build it, this whole thing, including everything, all the material, because it is logs, straw bale, plaster, everything the family could do, friends could do.
Yeah.
So, which can, but that cost is only what, 10 or 15% of the whole building cost? Modern homes.
So your materials in that kind of a construction are going to still be like 30 to 40% of your construction, and then
What about
your labor.
just talking about walls right now, not even the foundation, not even the roof, not about the
Oh,
electricity.
okay. So just the walls themselves, yeah, about 10 to 15% of your cost.
That is not much.
No. Your biggest costs are going to be roof and foundation.
Okay.
I mean, that's not finish work is by far the vast majority. Your finished work is probably half the cost of your building.
So that
But
is electric are running all over the
your electric, your plumbing, your ventilation, so you're like, heating and cooling, and then all of the finished fixtures, your flooring, your walls, all your trim, all of that, stairways, whatever kind of carpentry is done inside that building, all of that adds up to probably, I'd have to look to be for certain, but I'm from what I remember, it's about 50% of your cost.
and
Probably less than that. It's probably more like 40%, but still.
This is the problem, because this you can't really do anything unless you don't build anything. It's basically just have a kitchen with a water tap coming, like that's all. Otherwise, have a outhouse, and that's it. No other plumbing.
Well, this is kind of where you get into the discussion of what standard of living do we expect, when you start to change the finish inside the house, the cost and the skill required changes dramatically. And it doesn't mean that, people have to live in terrible conditions. It's just that there is certain, perception or certain expectation of a finish, the fit and finish of a house. And a house can still be very nicely done. So like in Mayapur, they have these houses, and pretty much everyone has their floors, all the floors in the Mayapur where I live, the Grihasta area, that they're all done with marble. This is marble floors. I mean, it's extravagant, but it's so cheap in India that all the Westerners, they all have their floors done in marble. And they had some houses done, same style, same construction and everything for the teachers, but they did them very simply. And so all the floors are concrete. So it didn't really change your quality of living. You had a nice house, but the finish was not as fine. And so just changing simple things like that change your cost tremendously,
Oh, good. That's a good thing.
So
And see, this is a philosophically pointed discussion about whether we should leave it to each individual to do. Should
yeah,
it be mandated? This is like a community-wise could also discuss, and they can.
exactly.
And so here in our discussion, I was trying to come up with these materials, building material. That's the I kind of wanted to, to understanding that these are something which is variable in like personal variable, either a community wide or a family wide. And
Right.
and this is only 10% of the cost, but it is kind of gives the whole feel,
Yeah. Oh yeah.
a huge like ambient feeling and living feeling, which is very much a psychological thing. But cost wise, it's not very much. So how can we reduce the cost? We have been discussing. I was telling the easiest way to reduce this cost, because electric pumping, carpent, I mean, all these things is to get it from China.
Yeah.
And get it in big container loads with some brokers around New York City. They are there who arrange this thing, and the cheapest way rather than buying it from Home Depot and such.
Right. Right.
But I don't know if there are ways to reduce these costs, and we can discuss those in subsequent ones.
Well, ultimately, the most reliable way to reduce the cost of building is, like you were saying, one, build in a method that the people who are going to live in the building and the people on the community, they can be involved, right? So they have some investment, so they own investment, they feel like personally invested in the construction. They can either contribute their labor, some arrangement with the project or something like that, or they get, the cost to hire them is much less or something, some arrangement. Okay. And then also, as much as possible, sourcing materials from the land, growing your own straw bales for the straw, harvesting your own timber off of the land. That is, those seem to be the easiest ways to maybe not the easiest, like you were saying, bringing things in with a shipping container.
Flooring could also be basically log, right?
So here's kind of the way I think about it is, if you are looking at building a village, a temple, a village, restaurant, a lot of buildings, you're going to need a lot of flooring. You're going to need a lot of logs, a lot of timbers, a lot of lumber, a lot of straw, a lot of, whatever it is for this. So what you would do is you would invest in some equipment.
Yeah.
And you would arrange for somebody involved in the project to be trained in the use of this equipment.
Yeah.
So for timber construction, a sawmill can be purchased, a mobile sawmill. I don't remember what the cost was for a mobile sawmill.
Oh, not
but
much.
they're like,
You can
I
get a
think you
small
can
wood
get a
miser for
really,
like 5,000 or 7,000.
That's
Yeah.
kind of what I was thinking. Yeah, a wood miser, if
It
you're
might not
looking
be
at like
mobile.
less than 10,
If you want one on
less than
wheels, it'd be more
10,000.
expensive.
Yeah, you can get them, but even less 10, maybe like really, really nice. One of the really nice ones, it's like $15,000. And you can pull it behind a trailer. You can move it to anywhere you need on the land and mill the wood right there. So you don't have to transport wood so much. You can even fell the trees and park the wood miser right there and uh, mill right in the forest, so you don't have to haul the full logs everywhere. So that would be a well worthwhile piece of equipment. You can cut all your flooring boards out of your own timber, or you can purchase logs, whole logs that you can cut if you want to use hardwood for your floors instead of softwood, because I think mostly what you have is pine on your land there. So that then purchasing the logs is much cheaper than buying the wood itself. But then you're spending the labor. The people involved in the project themselves, they're milling the wood and like that. And then it's a question: do you want like really finished lumber, or do you want, you know, how rustic are you happy with? Because that all changes. Rough sawn lumber is quite rustic, and so that's, like you said, that's kind of a personal choice of person
So,
living there.
I mean, just to give an idea of so we will have some like lot of devotee homes, both places,
Hmm.
and also then teaching places. Now, teaching in a sustainable and all these things could also be very rustic because people are
Right,
not really live in them. So, they can be like that. But when it comes to making visitor homes, we may need to make them, I don't know, maybe we just leave them like that if we don't want them to stay more than 2, 3 days. But if
right.
we would ask them to live there for 2, 3 weeks, that is what we are trying to do. Um, then we may need to make them more comfortable because
Right.
they're used to some comfort and they won't want to live somewhere.
Yeah. So those are kind of the challenges there. But then you invest in a sawmill, you invest in baling equipment. You may already have,
Then you
for
baling equipment.
and seeding equipment. So because you already have the tractor, so for seeding your own
We have all that.
straw. Yeah, so you have that already. So then some mixers, so you can mix the plaster, and
Mhm.
and then the rest of it is relatively, some saws and this and that, but that's where the cost goes in. Is it goes into the larger pieces of equipment for processing your own raw materials,
Mhm.
and then the training. You train some people to use them, and the training is relatively simple. It's not extensive in order to operate a wood miser or something like that. So yeah, so then it becomes a very viable approach, um, and then it's just a matter of getting groups of people interested in participating.
If you remember, I was telling that there are nearby colleges, and we
Yeah,
could
yeah,
get them to do one like log cabin, straw bale home, like what is this, masonry, these
yeah. You
four
can
four
you
different.
can definitely get students involved who are interested in
Yeah,
learning how to do this type of thing as part of their curriculum, part of their studies.
I mean, we can do a project base. So in one semester, four sets are there who are building these four cabins of different kinds.
Yeah,
County can become uh, this thing. They will become familiar with these codes, and then we watch over the 3 years how the whole seasonal they will watch and they will observe and they'll bring a report over 3, 4 years,
exactly. Yeah,
and then devotees also can figure out. It's like it becomes a living laboratory for us and for the wider community
yeah,
to
yeah.
aware of the four. And that's how I was thinking of doing these at least some devotee homes. And as far as the visitor homes and doctors' homes, I don't know what to do. So those may have to be. Anyway, so next week, can we discuss other than the cabin, like which, I mean, stick frame we don't need to, but what do you think we should take up next week?
We can discuss. Really like to discuss masonry options, because there are some masonry options that also the community can be involved in. We talked about this briefly before, you and I. And so I think that would be good, and that really lends itself well to larger buildings, larger construction. So you can build a temple or a restaurant, or something with more a hotel or something like that. I mean, even with the timber frame and the straw bale, a lot of these can be constructed, but it's a different type of construction. So I think that we can look at different
Excellent, Prabhu. What a wonderful,
other needs.
you gave us such a wonderful explanation, the foundation, literally. And okay, yes, Christoph Prabhu has done rammed earth, visions for child, definitely. Next week, then that would be great. Christoph Prabhu, you are over.
Oh, my wife wanted to say some things.
I forget now.
Oh no. Oh, never mind. The moment has passed.
Christoph Prabhu, would you be able to do rammed earth?
I think I remember.
No.
I think I do it. I just wanted to point out. Good. Can you hear me?
Who's talking to this here?
Oh, I just wanted to point out that when you involve more people in a project, then there's other added benefits of, first of all, the project being more fun. And then also just your project becomes more well known. People talk to their friends about it, and it has a more personal touch. And if we are talking about Varnashram I think means engaging people. So that's just another consideration.
Definitely, I'm all for that. I really want the projects to be such that people can build. That I've seen that in Rajasthan. I mean, everybody, I mean, women and children and everybody is making their own homes, and within a couple of days, the rooms are built. Those huts, so easy to build, and because they used to
All right,
just.
Prabhu.
Hey, Hare Krishna. Thank you.
Yes, I have to get going. Hare Krishna.
Haribol. Thank you,
You
Hare
very
Kirtan.
much, Prabhu. Christoph Prabhu, 2 weeks later, you could do rammed earth.
2 weeks later, I should do rammed earth. What is the question?
Now, next week, our Hari Kirtan Prabhu is going to take up masonry. This week, we did log cabins. And
right, and then in 2 weeks, say something about rammed earth.
Would you like to discuss about the rammed earth material? 1st of January.
That's 31st January. Yeah, why not?
We can have a good
I mean,
discussion.
I only have like really limited practical experiences in this regard. So, but
Start
a lot of theoretical knowledge.
Hari Kirtan and I, we have gone to some places to try to figure that out, and we can combine our knowledges. And so, Christoph, Bharat Prabhu, you want to do this thing, the earth bag building after that?
No. Yeah, I'm far away from anything experts accomplished or whatever. I just had that idea to build with earth bag here, and I looked into it, got a course and some books, and my family likes the idea, but just for something like a chicken chat or so. So I was thinking it's easy to do and kids can do it, and it's easy on the budget, but yeah, it might be a good idea for some facilities, but not necessarily for a woman who likes to have a beautiful house. And earthback can also look very wonderful if you do it nicely, but often it's curved, round structures. So yeah, there's not much to say about it. So if Christoph is speaking about rammed earth, I was thinking you're speaking about all kinds of natural building styles
One by
today.
one. No, no. I mean,
Yeah.
it's so much. You saw how much detail
Yeah.
I'm trying to figure out. I'm taking all your association to help try same thing as a part of college to try to figure out which materials and which climates are better given the current situation of the codes and energy efficient things and the labor costs and earthquakes and hurricanes coming so structurally and so many things so that's why I want to go one by one, one by one, one by one. And
Yeah. So rammed earth is very close to
out the back.
earth bags. I mean, there's not much not much that you need to know for earth bags besides filling the bags. And yeah.
Okay, Prabhu. Hare Krishna.
Hare Krishna. Hare Bol.
Hare Krishna and
Jai
Raman.
Prabhu.
Thank you very much.
Thank you, Prabhu.
Hare Bol, Prabhu. Ramananda Prabhu, you're there? You have a couple of minutes to talk?
Sure, Prabhu, just a couple of minutes. I do have to get going pretty quickly.
Okay. No, just wanted to see how you are. How is your family?
Oh, doing fine. Yeah, it's just we're braving the cold. Recently, we've been really focused on training the oxen because we just recently had them had rings installed in their noses.